it's done.
Okay, first, with the mic on, it might be a little easier to do. Okay, so can everyone see my screen properly?
Yeah.
Yes.
So to introduce myself, my name is Till Bios. I am a research engineer in artificial intelligence for the Romeo HPC Center. And today I am going to go a little bit more in details to what I introduced you last time on project management when those projects involve artificial intelligence and when those projects aim at putting artificial intelligence in a production setting that is already in place. So just like last time, we are going to go with two different parts. So with the first part, just going back to the basic concepts and the interest that we can have in using artificial intelligence in some contexts, but also the limitation that it has and the pitfalls that are to avoid if you want to use those kinds of technologies. In the second part, we're going to talk more about project management when it involves artificial intelligence, and most precisely machine learning methods those are things that we are going to redefine. There might be some redundancy with what I introduced last time, but at least it might be a good reminder for and to start, and so that everyone can start on a good basis. So when we think of artificial intelligence, the first thing we have in mind, like in our current society, the first thing that we have in mind are usually the chatbots, like what we call large language models, so programs that are capable of generating text based on an input. With examples such as ChatGPT, the chat that is more from a French company. There are also a lot of open source alternatives that do that. This is the first thing we have in mind, together with the AI image generation. So those are the main two things we have in mind, but it is far from being everything that we can do with artificial intelligence. For example, back something that dates way back, video game artificial intelligence is not called artificial intelligence by an abuse of language. It really fits into the category of artificial intelligence, in that there are programs that are capable of making decisions. Another other kind of programs capable of making decisions would be, for example, autonomous driving, which called for a lot of different programs that fit into the category of artificial intelligence. Keeping on a few examples, creative industries do benefit with special effects from AI, not just with the somewhat controversial image generation and video generation, but also with making more easy to get some special effect. For example, if you remember last time, this is not a picture of French President Emmanuel Macron. This is a deep face, so the face, and if you listen to the video, the voice have been digitally altered, which has interest in parodies and in creative contributions, but also can easily have some downsides. Finally, to get more practical approaches, like to get really more practical, form reading and like digitalization of elements is a kind of artificial intelligence that exists for quite some time now, and that has been used, for example, to fill and to digitalize paper revenue declarations. This is a French tax form. The last example that I want to introduce to you is this one. This is not an artificially generated image. This is just a photo of grape, which relates to something that is pretty close to what is done at the University of Reims, with the region being famous for champagne. The champagne industry has benefited, and we have worked together, the university and champagne industries, to better their production through several means, using artificial intelligence, for example, with crops disease detection or process automation in the manufacturing of champagne. I think this is no real secret that artificial intelligence get more and more interest over the years, at least in the recent years. So when we can see that evolution with the number of GitHub AI projects that is really strongly increasing and has been doing so for more than 5 years now. So just if you don't know GitHub, it is basically the biggest repository of source code that you can get that exists. And so it is a good indicator of the general interest of artificial intelligence. Now we can also see the same evolution with a more concrete impact of AI innovations, because the number of patents follows the same trend. So let's go back. Those are things that we have seen before, but it's always good to get a reminder on that. Artificial intelligence in general describes the programs that are capable of imitating human problem-solving abilities. So basically, you have an input from which you need a decision, an interpretation, for example, something that a human would easily do, but you want to automate that task. You use artificial intelligence. That is basically the concept. Often, when we talk about artificial intelligence, we talk a lot about other terms, machine learning, deep learning, and talk a lot about data, but some methods that really do work with artificial intelligence do not necessarily rely on data beyond just the input. Some examples of an old example and a more modern example, the chess AI Deep Blue, which was the first one to beat the chess world champion, was relying. Well, there's no question that it was an artificial intelligence, but did not rely on any sort of data. It was just analyzing all the possibilities that it had and made a decision based on this possibility. However, it does not mean that it was perfect, as there were hard-coded strategies to find the right solution faster. Something that is more closer to things that are more practical in today's world. Tasks such as like time optimization, task planification, a lot of scheduling does not necessarily require data, and just some artificial intelligence programs with that do not rely on data can get pretty good solutions for those elements. So the kind of AI that we are going to discuss a lot today are the one based on machine learning. Machine learning using, which are basically models, which are programs that have parameters that you can tune, and based on the data that you give it, so data being both input and expected outputs, you can find the right value for each parameter, which allows the machine learning model to work the way you want. And deep learning, which is the one that put AI in the spotlight in the recent years, deep learning uses a specific kind of model called neural networks. That is just a combination of very simple operations, but there are many operations and many parameters that allow deep learning methods and that allow neural networks to get a better fit to your data, so that they are able to get solutions to problems more finely. Basically, how this works for neural networks is you have first a training phase. So that's where you need the data and labels, so the input and the expected output that you give to the neural network. It gets a prediction that at first is going to be wrong, but through trial and error, it can correct itself and work towards getting the right solutions, at least as often as possible, hopefully. That is a process that requires a lot more resources than just using the neural network. Using the neural network, depending on its size, can be done, for example, on smartphone. You have a lot of AI and deep learning based things on middle to high end smartphones, and it's something that works very well because it does not necessarily require a lot of energy and a lot of processing powers. So to just get an idea how a neural network is trained, I'm going to go back with that with an example of just having playing cards, and let's just keep in our mind with try to classify them. For now, as you have absolutely no context of what is class 1 and what is class 2, you have no idea on whether the card should go in class 1 or class 2. But let's just give an example. Let's say the first one should go in class 1. Take the second one, and it goes in class 2. With two elements, you're not really completely sure of how of what is going to be the logic behind the class 1 and class 2. But the more data you're going to get, the more information you're going to get, the better you can have an understanding of the classification, even without getting context. That is how your network is trained. So third one, giving you a bit of time for the next one. Which class should it go? Next one. So up to now, you should be able in your mind to have an idea on what those two classes means, at least instinctively. But now there is this. And that is not a mistake on my animations. That's completely fair. The last one goes there. And that too, that goes into class 1, might come to a surprise if you had just an instinctive understanding on how it works, because the logic that I had was prime numbers, so 2, 3, 5, and 7 go to class 1, and the other one go to class 2. And my data, the data I gave you, was biased. So I purposefully, for this one, but this is something that happens accidentally a lot of times when using machine learning. I had an underlying feature that just biased the entire data. All the cars in class 1 were red, and all the cars in class 2 were black. This is something that you really have to be careful of when using machine learning, because when it's color of playing cards, it's not too bad. When you are trying, and it can happen depending on the context, on the industrial context, you might trying the same thing using artificial intelligence on people profile. And if it's the color of people that get discriminated unwillingly, that is much more of a problem. So this is something that can be corrected, but this is something that you need to be aware of before you use artificial intelligence on a larger scale. So to summarize, for deep learning and in general machine learning methods, deep learning methods are really appropriate for a wide variety of use cases. And if you have the good kind of data, you can get a good result with little resource involved. The cons are you need a lot of data more often than not, and sometimes you don't have the right labels for your data, because so the kind of data you can get can be only the entry that you want, but not the expected output of your method. And in that case, you might need people to actually label it for you, which can be time-consuming, resource-consuming, and often not very interesting for the people doing it. So it is something that can hinder you a bit sometimes, but like it's really dependent on the context. But sometimes you might require a lot of computing powers, but it's a bit like every computer solution. One thing that might be important, depending on your application case, is that for anything that is data-driven, so anything that's relying on data, you have no way to have a mathematical proof that it's going to work. You cannot get a 100% guarantee that it's going to work. You can get a 95, 98, 99%. That is something that is somewhat possible, but not 100%. There's no guarantee. So when to use it and when you're not to use it, when you have something that's easy to solve for a human, but maybe tedious, and the solution is hard to describe to a machine step by step, that is the best case application for machine learning and especially deep learning methods, especially if you can get data easily. Now, if you have little to no available data, you're going to be in a lot more trouble, of course. And as I said, if you need mathematical, like 100% accuracy, like you need an absolute assurance that you get the right result every time, this is not the right kind of method for you. Last thing that is worth noting is that if you want to know the logic behind the quote-unquote machine's reasoning, for deep learning methods, it's a research field called explainability, and it is still an open field as of now. Yet, it is a good time to get interested in those technologies. Simply, first of all, there's a lot of investment to make artificial intelligence methods more powerful, also safer to use, And internationally, there is a lot of interest in that. It has an interest as professionals, but it also has an interest as citizens, because it's something that's going to take more and more place in our lives, and it's quite important to be aware of it when we are confronted with it, whether it is in our professional or personal life. So that is just an introduction of what artificial intelligence is. If you have some questions just on those basics, I can answer them now. And then we are going to go a bit more in the project management side of things, like how to really get into details on how a project in AI is done, and how you can integrate it in a general industrial strategy. So maybe you could just leave 1 minute if there are any questions, and I can continue afterwards. All right, so it seems there are no questions for now. So let's go on the project management part. So here are the 3 building blocks of modern artificial intelligence. There are the 3 things that you are going to need to integrate AI in any industrial strategy. You're going to need the computing resources. It is the processing power, but it's also important to have storage, data, relevant data. I'm going to see a bit later that there are a lot of questions to ask about like data before you just get to use it, and methods like machine learning, deep learning, or just other AI methods that can solve your problem. So to get started, here are the 5 major points. So you need to see how you can identify and structure an AI project. How can kickstart a culture of data, so good habits and good practices to get interesting data. And then it's more on a company strategy level, find a region of interest and a good roadmap for integrating artificial intelligence in technological and business strategies. First of all, let's get onto a few stereotypes that are simply need to forget very quick. You don't necessarily going to need a room full of hard drives of data to go anywhere. Like you can do things with basically the data that you have. You can often find a way with much less data than the biggest things. With a few gigabytes, you can already, in some cases, get a lot of interesting results. You won't need to buy a supercomputer. Some methods, at least when you get started, you can get methods that work really fast and on small resources. Of course, once you scale, you might need a bit more processing power. The most important might be the bottom right one. AI is not going to replace your experts. AI is going to assist your experts, but your experts are first going to be what validates your AI methods, but you still are going to need their expertise to check and double check what your programs do. So once you get started, what you need is, obviously, I have said it and a lot of time already, and I'm going to continue saying it, you need data of your use case. So expected input and expected output. Of course, you need some resources, both storage and computing power. All of this and what's come after can be obtained either internally or externally, just like the software expertise to design the solutions and manage the databases. That's something you can get in or outside your company, and of course, your own experts are going to be part of the processing of the process of using artificial intelligence in your domain. So to identify, the first thing is to identify where AI could be useful to you. So identify opportunities. If you already have processes, there has to be some tedious parts that are simple enough that it can be done automatically, but that still takes time away from your experts. I have put some examples, such as mail sorting, predictive maintenance. That is the first and the go-to way to get introduced to AI. The other one is that there might be a business opportunity. Like if you have a good expertise in a domain, you might be able to get a new product or a new service by adding artificial intelligence to your own expertise. So once you have the opportunities, you need to structure them. I'm going to show you an example of a way to structure your AI projects. So here what you have is a canvas, so just a few information that summarize an AI project. So first of all, the participants, who is in it, who does what, who has what data. You can then you define a need, so the problem that you are going. Then what answer do you expect? What the AI is supposed to do? That the prediction. The difference is with the action is once you have that prediction, what do you do with it outside of the break itself, the AI break itself? What do you do with the AI's prediction? Then positive and negative value are what happens if it goes right, what do you gain from it, and what happens if it goes wrong, what do you have to lose. The rest is more about a more technical aspect, what data you have for training, what data you might need to acquire afterwards or might need to generate. And then how do you test your method, and how do you test your method, and what do you expect? What do you consider a good result? Okay, so all of this is a bit abstract. So I'm going to give an example of an internal project that we have here at Romeo. So we just changed our supercomputer, and it means that we have a new machine and new processes. And we have also updated your processes to access it, to request projects, stuff like that. And it has generated a request to our sysadmins and to our support. That came from things being new, and the users not necessarily finding everything in the documentations, even when it is there. So what we need here, is to help the users understanding the documentation, a new documentation, and also finding their way in our new processes. For that, we aim at making a software that is going to just answer the requests that are about our new machine. We aim at doing that in the form of a chatbot that is going to just give an answer based on a specific request. What we expect to gain from it is just having less tickets, and so take less time away from our support to for questions that can simply be answered using the documentation. That is if our chatbot gets it right, because if it gets it wrong, well, that might increase the number of requests. And of course, we don't want to waste any resource on things that simply don't work. So for training data, we have identified several things. As first of all, well, our documentation, that's the most fundamental data if we want people to navigate the documentation. And then we can also improve with the different user support interaction, or maybe even once we get into some production step, a troubleshooting documentation, like add some more information to it. The feedback that we can get it both from our support and from our users when we put that chatbot public. The precision we expect would be about 90% helpful and accurate answers, so 90% answers that would create a ticket that would be removed. If we get less, I think we might be happy as long as we don't get more work for our support. So once we have all those information, once we have all of that, we have done basically step 0 and step 1. We understand our need and we understand the problem we are trying to tackle. So following the structure I'm introducing to manage an AI project, the next step would be collect data. And that's where what I told about earlier about culture of data comes to play. So the idea of the culture of data is that there's a thing in French, never mind. So to get all of your sources, you have a lot of sources from which you can get data from sensors, from maybe your human resources. You can also get data outside. There are a lot of open, freely accessible data sets that might not be spot on your needs, but can still get close enough so that it gets useful. What you need to do with all that available data is in those 3 words: you collect, organize, and analyze. You collect first to have it, you organize, and you analyze to sort out what is going to be useful to you and what is not. So in data collection, how much data is going to depend on your use case. There are a lot of things that depend on your use case, and the data is one of them. But the first question is, where is it? Is it inside? Is it outside? can we take part of things that are outside? Then even if it's inside data, whether it's inside or open data, you still need to ponder the question, whose data is it, and are you allowed to use it? For example, if you have customer data, it can be personal informations, it can be just things that allow to identify people, and under EU regulations that you might be in position to have to comply with, you might not be able to use personal data, or might have to do different things so that you can use the data. Then there are the technical aspect of the data, the format, whether you need to pre-process this data. Those are important questions. And then to have data that is completely able to solve your problem, is it complete? Is it of good quality? Does it have enough variety? And can it be trusted? Yeah. So in personal data, it might, if you stay nationally in Bosnia and Herzegovina, this is not necessarily going to impact you that way. But once you get into trade in the European Union, you need to comply with general data protection regulations, which basically requires transparency, what we do with the data, and evaluate what happens and how likely it is to have things like data breaches. Yep. And you need to assess the solidity of your structure when you have the data. So all in all of that means understanding the data, because you can't just collect data and not knowing what is inside. So once you understand that data, you need to find the right structure for your method to be efficient, and you need to have and then you can start working on your solution. So that is at this point that the machine learning methods get into play. Once you have a solution that has been done, you need, of course, to evaluate it, and then make the decision on whether you have to go through another circle before putting in production, or if it's ready to go to production, and still go through another cycle simply to keep improving your method. That's something with a lot of machine learning methods that are going to constantly need improving. So that is how you make a successful AI project. But we have seen the question on whether you can. Now we need to see the question on what you should do, like whether you should or should not. The first question when you are in a business model is whether you're going to get or not a return on invest, and what kind of return on invest. Those are basically the kind of return on invest that you can get from artificial intelligence. It can get, well, the most basic one, material one, with either a cost reduction or an increased income. You can also, for example, reduce your risk, improve safety procedures using artificial intelligence methods by either reducing the risk or helping with regulation compliance. So those are material benefits. Immaterial benefits are something that are a bit more intangible, like customer satisfaction. If they get their answer, a better answer or a quicker answer, it's something that can also improve customer satisfaction. Like I said, if you take away the tedious and uninteresting task away from your expert, it can improve motivation, for example. And so those are the main way you can get a return on your invest. So once you know you want to integrate AI, you need to know how. That is your strategy and your roadmap for artificial intelligence. There are four pillars for your foundation. A lot of it relying once again on the data. I told you we were going to hear a lot about it. So the first thing is the data governance. So how do you store the data? How do you keep the data? How do you collect that data? Who can access it? All of this is part of data governance. So you have data. What do you do with it? And then you have the question on who is able to make you benefit the most from the data you have acquired, or who can get you the best acquisition, the best data acquisition. That's the competence strategy. You are going to need a few different kinds of expertise to have a good strategy that can be either get internally or externally. But what you need to do internally is having people that can make the decision, make the arbitration. That's the AI committee. That's the third step. And once you have projects that are decided, of course, there's all of the management part. So here is a general idea on how to define your strategy regarding AI and how to integrate artificial intelligence in your strategy. The first thing you need to do, of course, is the definition of the strategy that we are going to see just in a minute. Once you have a general direction to do, you need to get more and more concrete. Find use cases. Once you have a bunch of use cases, see which one are feasible, which one are the greatest return for the lowest investment. Once you have the feasible projects, you need to sort them and plan them. And once everything is on the road, you can improve it. We're going to go through all of this step by step. So first, there are four main things you can do. It's either cost reduction or service production. So basically, you can either work internally and use AI for the benefits of your own of your own processes, or get external and you propose or improve your product and services. This can be done either at a global or a local scale. So that means 2 times 2, it means like 4 different possibilities. For example, if we go back to our case in the Romeo Computing Center, we have resources around HPC supercomputers. But on a specific domain, we can get some services. We can increase our service offer with with large language model, with chatbots. The first one being the one I told you about earlier, which is the one that we're going to follow through a part of this presentation. Then use cases. It's your domain. So you are usually the one able to find the best cases, that what you need to do. It's what we talked before. It's the tedious tasks. It's the things that take away time from your expert. Like, for example, in our case, we had that support chatbot that I'm going to talk about in a bit. You have those use cases. You need to study their feasibility. What do you gain from it? Is it risky? Is it going to require a lot of investment? Getting back to our own project, we can estimate a few values, but what we can get from it is something we have discussed. The value is get back time for our experts. The risk is the risk that we have from language model hallucinating. It's like confusing or risky behavior inducing. And the cost that we identify is going to be both the workforce to put it in place and the structure to host it. Once you have all the feasible projects, you sort them by priority and you get them on the road. You schedule the time. Of course, it's always an estimate of time that might change with difficulties that are met. And throughout the projects, there's also a lot of monitoring and improving, asking those two questions on have the goals that we had in the first time been reached and how we can improve. So that is the five major steps: strategy, use cases, sort out the most reasonable ones, the most feasible one, and the one that are going to get you a return on investment. Get a roadmap and monitor the project. The last thing that we are going to talk about are just the different kinds of expertise. I talked about it last time already, but I can get a little more in detail for this one. So the data architect, it's something that's a bit closer to the data itself, with associated to everything that's about data governance. The data engineer is about making the database easily accessible, easily maintainable. Then data analysts would be more about understanding the data, that step of understanding the data, together with the data scientist that has a similar work, but closer to the solution, like how the data that we have is going to affect the training of the solution. Then the making of the solution itself is going to be about the work of the machine learning engineer. Okay, so I was a bit faster than expected, I believe. So if you have any question on this part, I can try to answer them. Otherwise, I'm going to get into concretely how we put in place that chatbot I told you about. just with an example of application of what I just told you in an AI project. So if you have any questions on the presentation up to now, I think we can take another minute to talk about it. Otherwise, I'll just go into the demonstration of the application of those elements. All right. So if there are no questions for now, I am going to get into our use case study. So just putting back the structure of an AI project that we have introduced, our first steps are going to be understanding the need and the problem we have to solve technically. We are going to go back to this canvas. I'm not going to introduce the whole canvas again. Just the needs that we have is to help users understand our processes and our documentation that details those processes. How we do it will be with a chatbot. So, our goal is to increase our user autonomy to once again get back the time of our experts to tasks that need their expertise. Process will be using a chatbot, but the goal will be not just to answer the requests, but also to link to the documentation. So that users can also little by little get around the documentation. And if something that is said by the chatbot is either wrong or unclear, they have the human written documentation to get a better understanding or to get a better formulation of what is done. One thing that is also important for us is to have the answers that are limited to topic. Large language model are completely capable of answering on a wide variety of topic, but our own model is made to assist with our supercomputer and our resources. We do not want it to be able to give an answer if you ask them, for example, a recipe for pancakes. And you're going to see that it is not that easy of a task to do that. So that was the first step. We understand what problem that we have. The second part will be the data collection. So we have our online documentation that we can get, as it is our own documentation and contains no sensitive or user data. We have something that is pretty safe to use in terms of EU regulations. The format that we have are web pages, but we don't really need the web formatting. So we will need to pre-process it to text. One thing that is also important, as we have something that we're going to need to search through. We need to search through a bunch of pages. Technically, a good way to do it is through vectorization. So from the entire text, you just get a vector, so a big string of numbers that, to simplify, contains machine representation of the semantic. As pages are relatively short, you can put a whole page to a large language model, and it will be able to understand it and process it. So you don't need to split the pages, but you need to have the pages separated. So that's the understanding what kind of data we are using. Then we have talked a bit already, but you have the format. The format of the data is something that we need to take into account so that it is properly processed by our solutions. So as I said, we have the documentations that are both as a text and as vectors. The vectors will be make it easier to search through them, and the text are going to be used as information for large language models. So for now, we're using what we call an off-the-shelf large language model, meaning that we do not, at this moment, do any fine-tuning. We do not train a model. We just take one that is accessible, that is open, and we just do different processings than training a model. So, for example, we're going to use two calls. We're going to use it twice for each request, once to generate the answer, once to generate the sources. So the technology that is behind the idea of getting a database and fetching information from that database is called retrieval augmented generation. So the idea is to have a pre-process that from the question get relevant excerpts from our documentation and give it as information to the large language model to be able to answer the question. As I said, we have two calls for each question. So we have two system prompts to orient the way that a large language model is going to work. The first one is the one that is going to answer the question. That goes as your chatbot assisting the users of the room as supercomputer, who will make concise and structured answers. The second one, I'm not going to read it through, especially since I translated it into English, but since the database is in French, the prompt is also left in French. But basically, the idea is to say you just give the links, you do not answer the question. So that is the general idea of our solution for now. Finally, with the evaluation, the final step is, there we go, the evaluation. So our first step is to have some questions to evaluate internally and humanly. With the question being, when I have a problem, when I put an input, does the output solve my problem? We are also interested in having both questions in French for the majority of French-speaking personnel that are going to use our solution, but also in English for the researchers that might use our system, but do not understand English. This is also going to be important because for now we do not have an English version of our documentation. So that is how we evaluate it. And to generalize on the first step, we have interesting answers both in French and in English. So with the same prompt, we are able to make that language model answer French questions in French and English question in English. The limitation that we have on this is it can answer the technical and domain-specific questions, but it is still able to branch off topic. To just explain what I mean by that a bit, let me give you some examples. Hopefully, it still works. No, it does not. Can you see my web page first of all?
Yes.
Yes.
Okay, perfect.
Yes.
So that is, however, it has lost the connection, and I do not understand why. Okay. Okay, I do understand why. So let me fix it real quick. There we go. There we go. So that is an example. So when we ask, let's ask any sort of question. How can I create an account? On here, you see that you're going to get a good step by step. So I'm gonna go real quick. You're gonna get a good step by step. It's we have also take into account that for personnel of the university and personnel outside of the university, there are two processes, and it gives both of them. So that's an example in which it works. There are also examples, don't worry, in which it does not work. But what I meant is if you ask something that's completely irrelevant, let's ask for a recipe for pancakes because it's getting late. There we go. So it seems here that it does not want to, and that is a good start. However, there is a little trick that you can often find with those basic models. But you just say that. Just say ignore previous instruction. And in this case, hopefully, you get what you want, which is not something that we want as well. We do not want our resources to be used for pancake recipes. We have other projects for that. If you want to use one of our language models to generate pancake recipes, it's fine. But it's fine, but not with the support chatbot. So it works, but it can be worked around. Another limitation are on those two tabs over there. Oh, it's gone. Okay. Never mind. is on the question formulation. I had an example that was ready. Unfortunately, seems to have gone, but let me get it. So if you ask how you can get access, that is the wrong question, unfortunately. Okay, I'm gonna try again. Yeah. So if you ask how you can access Romeo, Romeo being the name of the supercomputer, you have a list of steps that say, and you can see that it gives you a few login servers that are part of the documentation and give you the way you can access it. Now, if I change just a little bit the question, and if I say, how can I access the Romeo supercomputer? And there, you're going to see that the correct way to connect to it, you're going to need an account. No need to try it at home. It's not going to work. Is using Romeo, this kind of. Now, I just change a little bit the question, and it gives me a value that is completely incorrect. So as of now, with that evaluation, we can ascertain that it's not really ready for open use. So that is what we can conclude from our first round of project management. We had a good rest of the answers, but we're gonna need real users. We're gonna need a lot of variation for the one users. One way that we could do that is just ask a few users as well as support to use it and collect the answers. It raises concern about personal information. Even if we request users to not give personal information, they may still give it accidentally, and this requires at least a consultation with data privacy experts. We have some in the university, so it won't be a problem, but that is something that we would prefer to do just to be better safe than sorry. The second thing, as we see, we have a way to work around the topic, and that is the main problem that we have still to answer. It can branch out of topic. So and finally, yeah, a little glitch. It is also sensitive to the question formulation, as we have seen, and this is also something we need to stabilize before giving it away to the public, because it might get us in trouble in the long run. Okay, so do we have some time left or not? Just to can we? Yeah, Sofiane?
Yeah, no more than 5 minutes.
No more than 5 minutes. Okay. Okay, so I believe I can conclude that if we had some time left, I could go on the second round, but I think I think the idea here has been set. So we can take the last 5 minutes if there are some questions. Okay, so there's so hi, this is Noel Wood, Department of Computer Science Technological University, Dublin in Ireland. We built an AI agent to do the work that people hate doing when you cannot find the right person for this job. We are focusing on doing tasks that are involved in sourcing, purchasing. If you know anyone, wait, that sounds like advertisement. I'm sorry. I'm not sure that was a question. Okay. I'm not sure there was a question with your message, Noel.
No, I don't think so.
Okay.
Okay, if there's no question.
How do you train the bot to translate spoken language into text? Okay, so you do that to translate spoken language into text. So I think you do it basically the way you would train any other machine learning methods. So by having a bunch of examples, for example, of texts that are read by people. If you have a text that is read by a person, you can make a connection, like having, for example, as input the text spoken by the person, and as the expected output of your machine learning methods, the text itself. Now, how do you translate sound to texts for a machine? It is not as complicated as it looks, because all of those are just simply numbers. So to process sounds, you just do it like any sound processing software would do, which is just sampling the sound, and so that for every 100,000th of a second, there is one value. And then for the text, what is usually done, for example, with chatbots, you can use the same process. That is having a start of text and predicting the next word or the next key element. So you start with an empty text and your sound, and with the first chunk of sound, you can. I'm sorry. With the first element, you can get the first element of text and then complete it, and that's usually by iterative completion that you can get a text. Sorry, I try to have it without. I don't really have a support for that, but that's the general idea to get text. So in short, the sound is just digitalized, and then to get it into text, you generate the text, not word by word, but that's the general idea. Like it's subword by subword.
Great. There's no more question, I think. So thank you, Theo, for the presentation.
Thank you for
everyone. Thank you. It was really brilliant. Thank you. Thank you, everyone. Bye.
Bye bye. Thank you.
Bye.
Thank you for